there are four scales of measurement: nominal, ordinal, interval, and ratio. Your variables are going to be measured using one of these four scales, okay? Nominal scale variables have values that serve as names or labels. As an example, gender has male and female. So if you assign 1 to female and 2 to males, then the numbers simply serve as labels, okay? Now you could leave it gender, male, female, but that's not recommended with SPSS because you always want to convert your data to some numeric value. Now for ordinal scale variables, the values serve as labels and also indicate relative position or order. Okay, so as an example, we have age groups where we have 1 equals 18 to 24, 2 equals 25 to 29, and 3 equals 30 to 34. The numbers serve as labels because they share the characteristics of nominal scales, and they also give you insight into the relative order of the age groups. So as the numbers increase, so too do the age groups. Okay. Now you can also have preference rankings where you're asked to rank a list of items from a 1 equals most preferred, 2 is second most preferred, 3 is third most preferred, and so on and so forth. Now, for the interval scale of measurement, the values also serve as labels. They indicate relative order, and they give you information about the distance between the values. Okay. Now, because you have information about the distance between the values, you can actually compare the values to one another. Now, this means that we not only know the order of the values, but we also know how different the values are from one another. Okay, and I'll go into more detail on the next slide. Finally, we have the ratio scale of measurement. And ratio scaled variables have all the characteristics of the other variables, plus the scale has a true or meaningful 0 point. Okay, and the distance between the values are divisible. This simply means that if you have a value of 10 and a value of 5, the value of 10 is 2 times greater than the value of 5. Okay, now I'd like to mention two other things. So the ordinal and nominal scales are considered categorical. So any variables that have ordinal or nominal scales are considered categorical variables. All right, and any variables that have ratio or interval scales are considered continuous variables. Now, continuous variables are important because for t-test, ANOVA, and all your parametric tests, your dependent variable needs to be continuous. So it needs to have an interval or ratio scale. All right, that's very important. And your dependent or independent variable is generally either ordinal or nominal. Okay, categorical in nature. Now, let's explore the differences between ordinal, interval, and ratio scales. All right. So let's say we have a situation where I was asked to rank vanilla, strawberry, and chocolate ice cream based on my preference. And I gave the ranking a 1 for vanilla, 2 for strawberry, and 3 for chocolate. Now this is an ordinal variable. And the reason why it's ordinal is because the values serve as labels and they give us information about the order of the preference, but they don't give us any information about how much I like or dislike the ice cream flavors relative to one another. That information is only provided if you have an interval scale. So let's look at our next example. Next, I'm asked to rate each of the ice cream flavors on a scale of 1 to 5, where 1 is strongly disliked, 2 is disliked, 3 is neutral, 4 is like, and 5 is strongly like. Now, here we see the difference in the scales. We see that there is a unit difference or a unit description for the rating scale. Whereas for the rankings, we have no indication of the differences between the values. Okay, so that's very important. Secondly, the distance from 1 to 2 in units, psychologically speaking, is equal to the distance between 2 and 3 and 3 and 4 and 4 and 5. Okay, so just keep that in mind, that there's a unit measurement and that the unit change is equivalent from one value to the next when looked at consecutively. Okay, so again, the change from 1 to 2 is the same as the change from 2 to 3 and 3 to 4 and 4 to 5. Okay, the changes in consecutive values are the same. That's very important. So here I have a rating of 5 for vanilla, 4 for strawberry, and 1 for chocolate. We still maintain the ranking because I still prefer vanilla over strawberry and strawberry over chocolate. So we still have the same information we had in the ordinal scaled variable, but we have some additional information because now we see that I dislike chocolate compared to vanilla much more than I dislike strawberry compared to vanilla. Okay, so we can make that comparison based on the interval scale. Now let's talk about this arbitrary 0, or the fact that 0 has no meaning. Now here in the interval scale, I could have rearranged these numbers such that strongly dislike was -2, dislike was -1, 0 was neutral, 1 was like, and 2 was strongly dislike. Because the numbers don't matter. It just matters that the units are the same between the numbers. Okay? Now, with ratio scaled variables, 0 is important because if the cost of something is 0, then that means it's free. So there is an absolute meaningful 0 point with that variable. If your income is 0, then that means you have no income, right? So there's an absolute value, a meaningful 0 point with income. Same with age and weight. If you have 0 weight or 0 age, you don't exist or you're not born. Okay? Whereas with interval data, 0 has no meaning. Okay? So let's go into a bit more detail on scales of measurement. So let's look at some examples. So nominal variables. Gender, right? Where you have 1 is female and 2 is males. Well, you could switch that because, again, nominal scales are simply labels. The numbers serve as simply labels, so it doesn't matter how you label them. So females could be 2, males could be 1. Let's look at political affiliation. You can have independents, Republicans, and Democrats. Independents are 1, Republicans are 2, Democrats are 3. But independents could be 2, Republicans could be 3, or Democrats could be 1. Okay, it doesn't matter. The order doesn't matter because they're simply labels. Let's look at ordinal variables. Age groups, 18 to 24, 25 to 29, 30 to 34, 35 to 39. Now there is an order to these groupings. So therefore, not only do the numbers serve as labels, but they also indicate order. All right? So that's the difference between ordinal and variable. Again, we have rank, first, second, third, fourth. So we assign the appropriate number to the relative rank because it doesn't make sense to assign the number to an arbitrary rank. Okay, because again, these ranks indicate order. Let's look at interval variables. Now, math tests. So there are 10 questions on a math test and 1 point for each correct question. So if you get 0 right, then that means that you did not get any answers correct on the test. However, it does not mean that you don't know any math whatsoever. That's why the 0 is not meaningful. Okay? It does not mean the absence of the characteristic. It just means that you didn't score any answers correctly. Okay? Additionally, one correct question gets 1 point. So if you get 2 points, that means you got 2 correct answers. So the distance between 1 and 2 is the same as the distance between 3 and 4. Okay? Meaning that one question correct gives you a 1. 2 questions correct gives you a 2. 3 questions correct gives you a 3. Now, let's say that we change this to a 0 to 100 scale. We still have 10 questions, but now each question gets a 10 instead of a 1. We still have the same distance between scores, okay? Here, in the first example, we had 1 point between each score. Now we have 10 points between each score. So if someone gets 1 correct, they get 10 points instead of 1. If they get 2 correct, they get 20 points. If they get 3 correct, they get 30 points. So the distance between each unit is still the same. Okay? All right. Temperature. Again, we go back to this absolute or meaningless 0. In Fahrenheit, 32 degrees is considered freezing. Then you have 33 degrees, 34 degrees, 35 degrees. Okay, so each unit is the same distance. In Celsius, freezing is considered 0. So 32 is considered 0 approximately, right? So you have the same scale, but the starting point is different because the 0 does not mean the absence of temperature. It just means that's where the freezing point is. Okay, then you can go -1 if you go further down the line. But these numbers basically correspond with one another. So again, the 0 does not indicate the absence of something. It's just an arbitrary number. Okay? Now, we had the example before of strongly dislike equals 1, dislike equals 2, neutral equals 3, like equals 4, strongly like equals 5. But we could have changed that. We could have said that strongly dislike equals 0, dislike equals 1, neutral equals 2. Okay? So again, with interval data, you can change the numbering. The distance between the values is the same. So theoretically, the distance between strongly dislike and dislike is the same as like and strongly like. Okay? So let's look at ratio variables. Here we have an absolute or meaningful 0. You have 1-year-olds, 2-year-olds, 3-year-olds, 4-year-olds. So if you have 0, that means you have no age or you're not born. Okay? That's the absence of the characteristic. And then for money, we have $1, $3, $6, $18. But if you have 0, that means you have no money. That is an absence of the characteristic. That is the difference between ratio and interval variables. Okay?